So this is the full walkthrough tutorial of how we made our 6-foot skeleton file. So our stock dimensions are 880 by 1900. And for this demonstration, we're going to be using a 9mm plywood. So I have chose to reference my X and Y zero from the top left of my stock. So I'm going to start the file now by opening the SVGs that I purchased. So I put the link of where we purchased this skeleton SVG from in the description below. Okay, so as I open the skeleton SVG, you can see these tiny little vectors are down here in the corner. So what we're going to do is we're just going to open those up and make them slightly bigger so it's easier to work with. So I'm going to move them just off screen for the time being. And I'm going to do away first and foremost with these foot vectors. So these particular foot vectors are sideways and we want a full frontal aspect of this skeleton. So I'm just going to delete those now. So I'm going to start with the skull at the top and I'm going to double click on those so I've got the movement vectors, and I'm just going to drop that into the center of my sheet. So as you can see, I'm using the alignment tool to just sit that into the center. So next we're going to work with the rib cage, and I'm going to use the alignment features and just reference that. Now I'm going to move the chest portion up so it's close to the skeleton, but by no means touching, and I'll show you why in just a moment. So we're going to move on to the legs and the pelvis. And again, we're going to move that so it's closer to the torso, but not quite touching. So we've got the right arm and the left arm. Okay, so as you can see so far, our actual skeleton is taller than our stock. Now that's not a problem because I'm going to show you now how to easily change every single vector on the file so they all fit within our stock value. So I'm going to start down at the bottom right and I'm going to hold the left mouse button and I'm going to scroll so it covers all of our vectors. Then I'm going to come over here to the set selected object size. I'm making sure that our X and Y are linked. I'm going to change our Y dimension to 1800, which is nearest damn it 6 foot tall. So next I'm going to use our alignment tools again, and I'm going to set our model to be the center of our sheet. And as you can see, our skeleton has come together quite nicely. So there's a number of things that we're going to need to do to this file to ensure that it cuts correctly when we run the Smart Bench. So I'll talk you through those now. Okay, so firstly, we've got a number of small bone components. So what I'm going to do is I'm going to link all these together very simply by running a boundary. Okay, so I'm going to run an offset boundary around on the outside of our vectors. I'm going to make that boundary 6mm. So as you can see now, we've got our two sets of boundaries and we're just going to run some simple arced tool paths across the two just to link those together. Okay, so we've got one there and we've got one here. Okay, so now I've used magic scissors and I've snipped away the waste parts of our collarbone. I'm going to just realign that to the model and just tweak it so it sits correctly. While you're messing around with lots of small vectors, it's always worth highlighting all of those small vectors and pressing G on your keypad, and it will group all of those small parts together. So as you move one part, they will all move in unison until you are ready. Once you're ready, then you can press U on your keypad and it will ungroup all of those vectors again so you can then create your tool paths. Okay, so as you can see at this stage, we've made our collarbone section slightly bigger. We've created those outside boundaries, but as you can see, it's now messing with our model. So as we create different boundaries and we change the size of our model, we're now going to have to keep moving each part around to ensure that when we're cutting, these different toolpaths aren't going to clash with each other and give us false results. Okay, so the same thing for our spinal column. Because it's lots of small individual vectors, we're going to create the same size boundary around each of those vertebrae to lock them all in. And again, we're going to run the V-carve toolpath then to create the detail for each one of those vertebrae. We're going to pick up this bottom vector section off of the spinal column, and I'm going to hold control on the keypad and then press C and then press V. And that's going to copy and paste a new vector. So I'm going to move this vector up to here, and I'm going to use that to act as a neck. So as you can see, I've moved it up now, and I'm just reorientating our parts so it all fits seamlessly. So the last thing to do for this file before we create the toolpaths is to create a series of 4.5mm holes all over our model, where we're going to run the string then to connect each one of these separate pieces back together again once the file's cut. Keep saying it's going to be 6 foot, let's make it 6 foot. So let's take a brief look at creating some toolpaths. Okay, so to make this file really nice and simple for you, we're only going to be using 2 separate tools. One of them is going to be a 3.175mm compression end mill, and the other one is going to be a 60-degree V-groove cutter. So the internal and the external cuts are all going to be done with the end mill, and then we're going to depict all the bones and bring out all of that detail with the 60-degree V-groove cutter. Very simply, by holding shift on our keypad, we're going to select all of the vectors then that will have the internal cuts. That would include all of these little 4.5mm holes. So I'm very quickly going to do that for you. So it's worth noting on this toolpath, I'm going to create a 5mm lead in. That is just so when the end mill starts the cut, it's already going to be in motion, which is going to put less flex on the cutter. Find that out the accidental way as well. So the next toolpath is going to be the 60-degree V-groove cutter. I'm going to cut this actually as a profile pass on the line of each of our vectors, which will act as a V-carve, but with slightly less detail because we really don't need that V-carve detail. So I'm opening up Profile Toolpath, and I'm going to make sure that I'm cutting on the line, okay? Then I'm going to come down to my file for my 60-degree V-bit. I'm going to create a ramp, again with a 5mm lead in. And to select my vectors, what I'm going to do is I'm going to hold the shift button down on my keypad, and I'm going to start from the bottom right of my vectors. I'm going to hold the left mouse button, and I'm going to drag, and I'm going to pick up all of those vectors. Now, as you can see, I've picked up vectors that I don't need. So with the shift button still pressed on the keyboard, I can select and deselect any vectors I want. So I've got the teeth there. Now I'm going to move down to the vertebrae. And again, I'm going to pick up all of those vectors, and then I'm just going to go through and deselect the vectors that I don't want. So as you can see, the teeth now are still selected, and so are the vertebrae. I'm going to continue to do this for the hands and the feet. So really quickly then, I've picked up all the vectors I wish to select for our V-groove pass. And I'm just going to make sure that our cut depth is only 3mm, otherwise it would cut all the way through our stock. So as I recalculate our preview, you can see now we've got the internal cuts on our preview, and now we've got all the vectors now for our V-groove cuts also on the preview. I'm just going to go ahead now and create all the external profile cuts. So again, for the externals, I'm going to use a profile toolpath. I'm going to cut outside of the line. I'm going to go back to selecting our 3.175mm end mill. So for this, I'm going to go through and hold the shift key again, and I'm going to select all of the external boundaries. So at this stage, I'm going to add the tabs to my outside profile cut. For this, I'm going to open up my show in advance features. What this is going to enable me to do is to create 3D tabs as opposed to square tabs. It just means then when the Z head and the X beam are in motion, is you get a nice fluid up and down, and it stops little concave parts being cut out of your project. So we're going to select the 3D tabs, and I want mine to be 5mm thick by 20mm long. And when we go into edit tabs, that's now going to enable me to go round my project and put tabs wherever I need them. Now, it's always worth bearing in mind, if you've got two vectors that are close to each other, if you add a tab on the opposite side of each of these vectors, that these tabs will now bridge your cuts, and again, help to ensure that none of your parts come falling out of your wasteboard. So I'm going to go through now and just add each one of these tabs. Okay, so I'm going to take one more peek over at the preview of our file, and I'm just going to make sure that I'm not leaving any vulnerable parts that's going to come loose from our project whilst we're cutting. And I'm just going to look then to make sure that all the tabs are exactly where I want them to bridge all of the gaps. Okay, so as you can see, we've got our profile 1 and profile 4 up here are selected, which is both of our 3.175mm end mill cuts. We're going to click Save Toolpath, and we've got our skeleton here. So we will select that as large skeleton profiles. Okay, that one's now saved. And then we'll come up to Select Toolpath here, and we will just highlight profile 2. And as you can see, that's our 10mm by 60 degree V-carve bit. And we will just save that under large skeleton V-cuts. Okay, so very simply, we're going to go over to the beautiful Yeti Tool file transfer software. So once you've opened Smart Transfer, go ahead and select the machine that you want your files to be sent to. Go ahead and open up a separate window to find all of your G-code files. And again, by selecting one file and holding Shift, you can select all 3 of your G-code files and drag and drop them into Smart Transfer, and it will send all of those over to the machine for you. So now you've seen how we designed our 6-foot skeleton. If you'd like to see how we made it, follow the link in the description below. Cheers guys, bye-bye.